This is Geometry Lesson 8.1. We're going to be looking at perimeter. So that's something that you've studied all the way back probably to elementary school, definitely in middle school. So the big idea says a figure's perimeter is the measure of its boundary. The definition of perimeter says the perimeter of a polygon is the sum of the lengths of its sides. So remember, sum means you're adding up all of the lengths of the sides. So basically the perimeter is the distance around the shape. If you add up all the sides of a shape, that's the perimeter. So we're not looking at the inside, that's area. We'll get to that. But we're going to be looking at perimeter, something you've studied before, but obviously here in geometry we will take it to a higher level. So if any polygon has n number of sides, so if we're talking about a pentagon, it has 5 sides. Hexagon, it has 6 sides. So n just represents the number of sides. You can always find its perimeter by adding the n lengths. So if it has 6 sides, you can add up the 6 lengths that you have on those sides. But when some of the sides are known to have the same length, you can replace repeated addition with multiplication. For instance, if you have a 10-sided shape and all the side lengths are 5, instead of just adding 5 plus 5 plus 5 plus 5, all the sides all the way around, if we know there's 10 sides and they all have the same length, you can just do 10 times 5. All right, so let's run through some basics and then get to some more complicated stuff. So for example 1, we're going to write the formula for perimeter of each of the following shapes. So these are going to not actually have numbers. We're going to leave it with the variables. So a rhombus with side length S, what would be the perimeter? So if I told you that it was side length 10, most of you could very easily come up with the perimeter. But how do we express it with the variables? So we know a rhombus, a basic rhombus, looks like this. All the side lengths are equal. And so if every side length is S, just like if those were 5s, because they look like 5s, you would do 5 plus 5 plus 5 plus 5 to get the perimeter. So we are doing S plus S plus S plus S equals perimeter. And of course, I can combine those into 4S. So the perimeter of that shape is 4S. Now, what this was talking about up here is I don't have to necessarily start here to get to 4S. If I know all 4 sides are equal, then instead of adding them all up, I can just multiply by how many sides there are. So just 4 times S. Okay, a parallelogram with adjacent side lengths A and B. So we know in a parallelogram, opposite sides are equal, but they're not all necessarily equal. So your traditional parallelogram looks like this, longer sides here, shorter sides here. So we're going to call this side A. Now it says adjacent. Remember, adjacent means next to. So the adjacent side lengths are A and B. So if this side's A, so is this one. If this side's B, so is this one. So your basic perimeter problem would just be add them all up. So A plus B plus A plus B. That's what the perimeter is equal to. Of course, you would always simplify that. So you have 2 A's plus 2 B's, and that's your perimeter. You can't simplify any more than that. So if you knew those actual lengths, you could do 2 times whatever A was and add it to 2 times whatever B was. And remember, we can jump straight to this. 2 A's, just call it 2A. 2 B's, just call it 2B. And you're adding them together. We're not multiplying. That's area, length times width, and stuff like that. That's to find out the area on the inside. We're just looking at the distance around the outside. So we are adding. Okay, how about the perimeter of a regular hexagon? So regular means all the sides are the same. Hexagon is 6 sides. It looks like this. Think of your line of symmetry down the middle. You're going to have 3 sides on each side of that to add up to a total of 6. Hexagon is 6. If it's regular, all the sides are the same. And we're going to call them all S here in this problem. And so we would add them all up, S plus S plus S, 6 times. 1, 2, 3, 4, 5, 6. That's the perimeter. And we could simplify that and just call it 6S. And yes, you can jump straight to that. You don't have to write it out as repeated addition. Okay, so what about letter D? The perimeter of a regular n-gon with side length s. So whenever we just take away all the numbers, a lot of students get confused. My recommendation is always look back to what you would have done if you had the number here. So in this one, we had a regular hexagon, and it ended up as 6s. If it was a 10-sided shape, it would be 10s. So whatever the number of sides is, which is whatever n represents, so here was 6. Okay, you just take that and you multiply it by side length s. So that's why this was 6s. So whatever n is, you just multiply it times s. So it's going to be n times s. And that's the answer. You want to kind of draw a picture. We don't know the number of sides, so we just kind of draw part of a shape. We're not going to draw all of it, but we know all of these sides are the same. And so we would add up all of them, whatever n is, that's how many there are. And so we're just going to multiply n times however many sides we have. Okay, example number 2. Suppose a kite is drawn. I've got the kite here for you. And the ratio of the lengths of the two sides is 3:2. So first of all, in a kite, we know that these two sides are equal and these two sides are equal. That's what makes it a kite. You've got consecutive sides, two pairs of consecutive sides that are equal to each other. Now, this is not telling you that the sides are 2 and 3. It's saying the ratio is. So ratio is kind of like your fraction, 3:2. So guess what? 30 to 20 simplifies to 3:2. So that's a ratio of 3:2. So these sides could be 20 and 30. You could times this by 3 and you could have 9/6. 9/6 simplifies down to 3/2. Okay, so that is a ratio of 3:2. That could be the side length. So we don't know what the side lengths are. Could be any of these, but they're giving you the perimeter of 40. So if I add up all the sides, it's 40. Two of them are the same. The other two are the same. They're in a ratio of 3:2. They're going to add up to 40. How do you figure out the lengths of the sides? So it's actually pretty simple. Let's call these the shorter ones, represented by 2 in the ratio 3:2. You're going to call those 2x. And so I'm sure you can figure out. Then we're going to call the other ones 3x. So you're going to use the ratio to set that up. That's not saying this side is 2 or this side is 3. That's why we have the x there. Okay, the perimeter would be adding all of those up. So 2x plus 2x plus 3x plus 3x. And we know that the perimeter is 40. So we've got the ratio set up correct with our 2x and 3x. We know the perimeter would be all of these added up. Let's simplify that. 2 and 2 is 4, plus 3 is 7, plus another 3 is 10. So I've got a total of 10x, and it has to come out to 40. So we're going to divide by 10 here, solve this nice easy equation. X equals 4. Now that doesn't tell me what the side lengths are, but I've already got an algebraic expression to represent all of those side lengths. So 2x is going to be 2 times 4. So those sides are going to equal 8. And these, 3 times 4, is going to equal 12. Now that ratio, 12/8, if you were to go ahead and put that in your calculator as a fraction, 12/8 simplifies to 3/2. That is a ratio of 3:2. And if I added those sides all up, 8 plus 8 plus 12 plus 12. Double check myself, make sure that my math computes. 8 plus 8 is 16, plus 12, that's 28, plus another 12 is 40. So I've got two pairs of consecutive sides equal to each other. They're in a ratio of 3:2. 12/8 is 3:2, and they have a perimeter of 40. So first time through, that might seem like a little much, but you're just going to take your ratio and set it up here with x's, add them all up to get your total perimeter. It's going to be equal to whatever the actual value of the perimeter is. Solve it, plug your answer back in, and you've got your actual lengths of the sides. All right, if you flip this over now, this is going to feel a lot like algebra, which some of you will like, but obviously we're relating this to shapes. So it is geometry. So example 3 says, suppose n plots of land, so any number of plots of land. Plots of land is like when you buy a house, it's on an acre, that's a plot. Each is made up of a length and a width, or a height and a width, unknown values, right? But we have a measurement this way and a measurement this way. They are rectangles with given lengths, which we don't have, so we don't know the number of plots, and we don't know what the height and the width are here. But based on however many plots there are, we want to figure out if there's a fence built around not the entire thing, but each individual plot. They're all attached to each other, so all of these lines represent fencing. So in between each, separating each one, there is fencing as well, not just around the complete outside. If a fence is going to be built to separate the individual plots, how long of a fence is needed? So we have to write out an algebraic expression to represent this because we don't have any numbers here. So the solution here is to look for a pattern. So again, this will feel a little bit like algebra. So what we're going to do is first we have to find the pattern. So I think the easiest way to do that is to set up a chart or a table. So we're going to have our number of plots and how much fence is needed. We'll start with the ones that we can visually see, and then we'll come up with an expression that could represent any possibility. So let's just say there's one plot. We're just talking about this right here. If you got a highlighter, you can highlight right here. So I would have whatever number this is, let's just say it's 10. I'd have 10 here and 10 here. If this was 5, I'd have 5 here and 5 here. I don't have actual numbers, but I have h plus h, so that is 2h. And I have w plus w, so that's 2w. So again, if h was 10, be 2 times 10 is 20. If w was 5, 2 times 5 is 10. You would add those up, and that would tell you how much fencing you need for one single plot. Now, a lot of people would think, well, you just double that then, or triple it, or multiply it by however many plots there are. But if you take a look, if we're going to now go to two plots, one side of that second plot over here, if this is number 1 and this is number 2, one side of that was already fenced. So we're not actually doubling the amount of fence because we don't need to refence this side. It's already done. We only have to do 3 more sides. So I'm going to have this h, and this h. That's 3h, not 4, 3. And I have w, 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 w. I'm going to have 4 w's. All right, a little too early to pick up a pattern, but let's see what happens when I have 3 plots. So now I'm going to fence in all of this, each plot. So now I have 1, 2, 3, 4 h's. Now I start to see a pattern. And I have 6 w's. Okay, so now I want to come up with a pattern for n number of plots. So let's say there's 200 plots. I don't want to sit here and have to add all this up. I'm going to come up with a pattern, an algebraic expression that represents this. So look at this value right here compared to the number of plots. 2 compared to 1, 3 compared to 2, 4 compared to 3. The number being multiplied by h is always 1 more than the number of plots. So it's whatever n is, like 3 plus 1 is 4. So whatever n is plus 1 represents this number, the 2, the 3, the 4. It's 1 more than n, 1 more than the number of plots. That always gets multiplied by h. And then what about the pattern with the w's? 1 is 2, 2 is 4, 3 is 6. So you're always timesing the number of plots by 2 because you're always going to have 2. No matter how many plots you take here, there's always going to be 2 more W lengths of fence. So this represents 2n. I'm going to put in parentheses just so we can separate it. And that gets multiplied times W. So if I actually had some numbers here, like let's pretend that W was 30 feet and H is 90 feet. So all of these are 90, 90, 90, 90. And all of these are 30, 30, 30. And let's say the number of plots that I needed here was 5. I have 5 plots. How much fence? Well, all I got to do is grab this formula that I created. N plus 1 is 5 plus 1 times h, which is 90. And then I would add that. 2 times the number of plots, so this would be 10. I'm going to write it out though so you can see where everything went. It's 5 times 2 times W, which is 30. And that would give you your total amount real quick and easy without having to sit here and add. And I've already ran those numbers for you. This comes out to 840 feet of fence. All right, so what I would like you to do is pause the video and see if you can try this next example on your own. See if you can chart it out real quick, come up with the formula, and then press play again and see how you did. So I'm going to take a quick break here and let you go. All right, so you should have pressed pause and tried this already. Let's see how you did compared to me. So you've got your number of plots and your fence needed. Same problem, but different shape. Okay, so for one plot here, these are isosceles triangles. So all of these sides are equal to each other. They're all A, and the base of all of the isosceles triangles are B. So for one plot right here, I'm going to have two A's plus a B. Now I'm going to put the 1 in front of it, but you could just write B. So for two plots, I've got two of these now. There are 3 A's total plus 2 B's. Starting to see a pattern. 3 plots, all of this being fenced in. 1, 2, 3, 4 A's plus 3 B's. I've got another one here. I might as well throw it on there. So for 4 plots, I've got 1, 2, 3, 4, 5 A's. And I've got 1, 2, 3, 4 B's. So if I was going to project this out for any number of sides and I wanted to find the fence that was needed, this number, once again, is one more than this one. So I'm going to call this n plus 1 times whatever A is. And this one is actually not double like it was up there. 2 is 2, and 3 is 3, and 4 is 4. So this number is whatever n is. So we're going to call it n. I'll put it in parentheses so that it's clear. And that gets multiplied times b. So again, a quick example. Let's pretend that all of these are 50. All of these side lengths here are 50. And all of these side lengths over here are 25. So A equals 50, B equals 25. We'll just say it's feet. And let's say you had a ton of land, you're going to split it up. Let's say this was a farmer and they're building this to put animals in. Let's say you have 70 of these pens or 70 of these plots. How much fencing is going to be needed? So all I got to do is grab this handy dandy formula. N plus 1 is going to be 70 plus 1, which is obviously 71, times A, which is 50, plus. So that's going to tell me how much fencing I need just for these pieces. And then right here, whatever N was, so just 70, times whatever B is, which is 25. Those numbers here came out to 3550 and 1750. And so I quickly can figure out how much fencing would be needed for 70 of these pens that have sides of 50 and a base of 25. It would come out to 5,300